Hello everybody. Let's continue our lecture, Chapter 3, Sequence and Series, with subtopic 3.1c. After this lecture, students should be able to find the nth term of geometric sequence. Use the sum formula, Sn. First of all, what is geometric sequence? Geometric sequence is a list of numbers in which each term can be obtained from the previous term by multiplying a constant number called the common ratio and denoted as R. Common ratio denoted by R. A be the first term, R be the common ratio. Now we are going to derive the Tn formula for geometric. First term is A, second term is AR, third term is AR squared, and fourth term AR cubed, and so on. So T1 can be defined as AR to the power of 1 minus 1. Second term can be derived as AR to the power of 2 minus 1. The third term can be derived as AR 3 to the power of 1. The fourth term can be derived as AR 4 minus 1. Therefore, the Tn can be derived as AR to the power of n minus 1. So this is the Tn formula for geometric sequence. So now study this example. So how to get the common ratio? The common ratio can be defined when we have second term divided by the first term. 2 divided by 1 is equals to 2. Example B, the common ratio can be defined when T2 divided by T1, which is 2 over 3. And example C, the common ratio is negative 2 when T2 divided by T1 or T3 divided by T2 and so on. Noted here, common ratio can be a positive number, it can be a ratio number, and it can be a negative number, but cannot be 0 or 1. Cannot be 0 or 1. Now proceed to example 1. Given sequence 3, negative 6, 12, negative 24, and so on, find the nth term A, B, the ninth term, and if the kth term is 192, calculate the value of k. Now we try to solve one by one. For the first example, A, find the nth term. So from this sequence, the value of A, the first term, is 3. And the common ratio can be defined as -6/3, which is equals to -2. Plug in the value of A and R into our formula, and we have Tn is equals to 3 times -2 to the power of n minus 1. So this is the Tn formula for our question A. Question B, find the ninth term. For question B, the ninth term, using the value of A, the first term is equals to 3 and R is equals to -2 and the Tn is given before 3 times -2 to the power of n minus 1. Then what is our T9? Just substitute the value of A and R into our formula. Then we have T9 equal to 3 times -2 to the power of 9 minus 1 is 8, and the answer is 7, 6. And then solve the next question, which is if the kth term is 192, calculate the value of k. So now replace the n here with k. Therefore, it is 3 times -2 to the power of k minus 1, which is equal to 192. Then simplify this expression and solve. Then simplify this expression. We have -2 to the power of k minus 1 is equal to 192 divided by 3, which is equal to 64. Now we are trying to do indices rule, which is -2 to the power of k minus 1 is actually equals to 64 can be written in terms of -2 to the power of 6. Then by using the indices rule, we compare the index because the base is the same here. Then we compare our index, and we have k minus 1 equal to 6. Therefore, k equal to 7. So this is the answer. Now, proceed to example 2. Okay, example 2. Given sequence 12, -6, 3, -3/2, and so on, find A, the nth term, B, the 50th term. Then, if the kth term is -3/2, calculate the value of k. Now, try to solve question A first. So, given that the first term is 12, so A is equals to 12, and the value R can be defined as R is equals to -6/12, which is equal to -1/2. Okay, then substitute the value A and R into our formula, then the Tn formula is 12 times -1/2 to the power of n minus 1. By using this formula, try to solve question B. Find the 50th term. The 50th term can be defined by using the value of A equal to 12, R equal to -1/2. So, the T15 can be defined as 12 times -1/2 to the power of 14. Remember the formula for Tn. The formula for Tn equal to 12 times -12 to the power of n minus 1. So therefore, T15 is equal to 12 times -1/2 to the power of 14, which is equal to 3/4096. Proceed to the next question, which is if the kth term is -3/2, calculate the value of k. So similar with example before. Then we have the kth term is 12 times -1/2 to the power of k minus 1 equal to -3/2. And then simplify this. -3/2 is divided by 12. Then we have -1/2 to the power of k minus 1 is equal to -1/128. Now, using the same method before, comparing our base for our index, we have -1/2 to the power of k minus 1 and rewrite our -1/128 in the form of -1/2 to the power of 7. So now the base is the same. Then we compare our index. We have k is equal to 8. Is that clear? Now proceed to the next example, which is example 3. Nth term of a sequence is Tn equal to 5 times 3/2 to the power of n minus 1. Show that the sequence is a geometric sequence. That one is question A. And B, find the value of n where Tn is equal to 1215/32. Now, we are going to solve question A first. Show the sequence is geometric sequence. So for this example, you need to show the common ratio R in general form. So our common ratio R is equal to Tn over Tn minus 1. Now find the Tn minus 1 first. So Tn is given as 5 times 3/2 to the power of n minus 1. So now find Tn minus 1, which is equals to 5 times 3/2 to the power of n minus 1 minus 1. Just substitute n with n minus 1. So this is n, this is n, therefore this is n minus 1, this is n minus 1. So we have here, it is equal to 5 times 3 over 2 to the power of n minus 2. And then substitute into our formula. Tn is 5 times 3 over 2 to the power of n minus 1 over 5 times 3 over 2 to the power of n minus 2. Now, as we can see here, the 5 here can be cancelled out, and our ratio form, the base is the same. So we can use index rule, which is a to the power of m over a to the power of n can be written as a to the power of n minus n. So I'm going to follow this rule. So therefore, this one can be written as 3 over 2 to the power of n minus 1 minus with n minus 2. So it is equals to 3 over 2. So n minus 1 minus n plus 2. Simplify the index. So we have 3 over 2 to the power of n minus n is can be cancelled out. Negative 1 plus 2 equal to 1. So now noted here, our r here is a constant. So we can conclude that since the common ratio r is a constant, then Tn is geometric sequence. Now proceed to question B. Question B is given Tn is equal to 1215 over 32. We want to find the value of n. So, using the formula given, Tn is equal to 5 times 3 over 2 to the power of n minus 1. 1215 over 32. Then we have 3 over 2 to the power of n minus 1. This one is 1215 over 32 divided by 5 equal to 243 divided by 32. And then the same method or the same concept we are using now, we are going to make the base of our index here is the same. So 3 over 2 to the power of n minus 1 is equal to 3 over 2 to the power of 3 over 2 to the power of 5 is actually equal to 253 over 32. Therefore, comparing our index, we have n minus 1 equal to 5. Therefore, n equal to 6. Now, we are going to learn the sum of a geometric series, Sn. Sn is equal to a 1 minus r to the power of n over 1 minus r, or Sn is equal to a r to the power of n minus 1 over r minus 1. Either one, we can use both formula where r cannot be equal to 1. Example 4. The first term of geometric sequence is 24 and the common ratio is negative 32. So, given here our a and our r, find the sum of the first 4 terms. So, this is S4. So, now we are going to use the formula Sn is equal to A r to the power of n minus 1 over r minus 1. So then we have S4 is equal to 24 times r, which is equals to negative 3 over 2 to the power of 4 minus 1 over negative 3 over 2 minus 1. So calculate this expression, we have the answer is 39. Okay, now proceed to example 5. So given here, the first term of geometric sequence is 27 and the common ratio is 4 over 3. So find the first 5 terms. So this is S5. By using the formula for Sn, so we have S5 is equals to 27 times 4 over 3 to the power of n minus 1 over 4 over 3 minus 1. Calculate this expression, then we have 781 over 3, or it is equal to 260.33. Now, solve question B. So the list number is n when the sum exceeds 550. Sn is greater than 550. So substitute the value of A and R into the formula and it is greater than 550. Simplify this expression. We have 4 over 3 to the power of n minus 1 is greater than 550 over 81. Then 4 over 3 to the power of n is greater than 550 over 81 plus 1, which is equal to 631 over 81. Now taking log both sides. So we have log of 4 over 3 to the power of n is greater than log of 631 over 81. So by using the log rules, bring the n in front. We have n log 4 over 3 is greater than log of 631 over 81. Therefore, n is greater than log of 631 over 81 divided by log of 4 over 3. Then n is greater than 7.136. Therefore, the list number is of term is 8. So this is answer for B. Okay, before we end up our lecture for today, please do this exercise and submit to your lecturer. That's all for lecture 1.